Hello and welcome to this video on the advanced microdevices AM386DX DXL 33 MHz. Now this CPU is also available in a 40 MHz variety. That's not very fast in today's terms, but at the time it was the bee's knees. Intel stopped their processors, their 386s, at 33 MHz. One other interesting note is, I tried to make this video already, and for some reason the camera didn't record it. So I'm now having to re-record it all over again. Anyway, this is a 386 motherboard. If you've watched my previous video on the AST Computer 386 DX25, which is probably a running joke at this stage since I've mentioned it in every video so far, you'll notice that that particular board had this, my hand, going over both a motherboard and a daughter board, which is an add-in card. In the case of this board, all you have is a motherboard. The motherboard is a very simple design. You've got your memory slots on this 386 motherboard. You've got your chipset, which are these two files. I'll explain them a bit further a little bit later. And we've got your cache memory. You've got your main processor. You've got an additional PGA socket. I'll explain that in a moment. You've got somebody honking their horn outside because there's roadworks. You've then got this particular lovely chip from the Cmos. You've got the keyboard controller chip, BIOS chip. You've then got the system BIOS chip. Okay. You've also then got the power connector. So let's start in the beginning. The guy outside is honking his horn and he's making a terrible racket. But I don't know whether you can hear that on the video. This is what's known as an AT power supply. So the power supply we have nowadays is an ATX, which would have 20 pins or 24 pins. This is an older style of power supply, which is a little bit more simple. The problem with this particular power supply that linked into this particular product was that it didn't really support advanced power features, such as computer turning on automatically and computer shutting down, since there was a 220 volt / 115 volt physical on-off switch on the front of the computer. We can go into detail in a later video on the power supply. Today we're just going to look at the actual motherboard. Now this motherboard also has a built-in AT style keyboard controller. That's this fella here. It's the big style keyboard. I do have one there. I'll try to grab it from behind myself in a minute and I'll show it to you a little bit clearer. Okay, sorry, there's there. Now, what we also have here is the keyboard controller chip from Advanced Microdevices from American Megatrends. Now, American Megatrends are still a very large manufacturer of video BIOSes and such for computers in the computer industry. Now, the next thing we're going to show you are the slots themselves. Now, on this board here we have numerous ISA slots. ISA, if I've not mentioned it already, it stands for Industrial Standard Architecture. Now, one of these particular slots, one of the 16-bit slots, as I said before, this is 8, and this piece makes it 16. One of these slots was actually used for the controller card, which control both the hard drives, optical drives, and floppy drives on this computer. So, if you had an additional hard drive or floppy drive you wanted to add to it, you could take out the card and you could actually put in a more advanced EIDE or advanced ATA controller card that accepted the larger hard drives, as some of the controller cards for this particular motherboard would not have supported hard drives bigger than 540 megabytes. This is the main chip, as I said to you already. This is the CPU. Now, I just grabbed the keyboard there that fits into this slot here, the AT style keyboard. This is the AT style keyboard socket. Okay, it's as you can see, my hands are big, but as you can see, it's a fairly big socket. The newer style PS2, which is used in your module computer. Okay, here now. So there you have it now. That's the newer style here, and this is the older style here. This one. So this is what's known as an AT style. This is what's known as a PS2 style. Okay, PS2 was a style invented by IBM for their OS2 operating system. So they had PS2 style mice and PS2 style keyboards. Okay, So we have this empty slot here in the motherboard. It's known as a PGA socket. The reason why it's a PGA socket is it's what's known as pin grid array. So you got all these little holes here where you can actually plug in an additional processor. In the case of this board, the additional processor will be a MATS coprocessor for MATS capabilities. The AMD chip that's on the board at the moment does not have a built-in FPU/floating point unit. Therefore, you would need to install an additional FPU unit to allow stuff like AutoCAD to run this computer correctly. Without it, the computer just simply won't run AutoCAD. It will refuse to run AutoCAD. Okay, moving along, we're going to move along up here a bit. I was going to show you something very interesting. This little barrel here you're going to see on modern machines even today. This little barrel contains a crystal, which, when an electrical impulse is applied to it, oscillates at a certain frequency. That frequency is always the same. Therefore, the computer's frequency can be dictated by this frequency, as this is a known speed. So, for example, this computer's motherboard can run at 8 or 16 megahertz. Because this speed of this crystal is known, this speed can be used to determine how fast the motherboard is actually going. Is it going at 8 or is it going at 6? There is a jumper on the board to actually determine what speed the motherboard can run at. This motherboard can actually run at both the 8 megahertz and 16 megahertz. And you have here a little jumper, and as you can see beside it there, it says 18 clock 16, or 18 clock 8 and 18 clock 6. So 18 clock is the actual clock and speed of the computer. I've had this set to 8 for a long time, and it seems to work very well. The two chips on the board, which I mentioned earlier on, this chip and this chip, are the I/O chips. They basically control the likes of the RAM, how the computer interfaces with the video cards and the control cards on the board, and a whole range of other things. They're also known as Norton-Southbridge chips, Northbridge being the upper one and Southbridge being the lower one. More modern computers have these combined along with even a video card chip built into them, and they're now known as Super I/O chips, or Super Input-Output chips. We move up here for a moment and we'll show you this next chip. This chip up here on the motherboard is what's known as the Cmos or BIOS chip. Cmos is actually named after the type of material the chip actually uses, and BIOS, as you see here on the board, 386 BIOS stands for Basic Input Output System. But Cmos would have been the original name for this particular component. This BIOS chip is actually of a UV light design, so it's not a flash BIOS like a modern computer. For example, on a modern computer you can just install a floppy disk and you can flash the BIOS to the latest edition. This particular chip, unfortunately, if you happen to damage it in any particular way or peel back this label, you'll notice a little see-through window with the chip inside. The chip inside actually requires a UV light in which to program it. It is reprogrammable, but you need special tools in which to do it. So, if you happen to bust this chip, you have to replace it or buy yourself a UV lamp set. That allows you to program. You can't just get a UV lamp and stick it out in the sun. It doesn't work. Another nice thing about this particular board is it actually contains a cache. The cache is very, very good. Alpha 386 chips didn't really have much cache or any at all. This allowed for most common commands to be executed. The idea of the cache is basically like it predicts what command you're going to choose next. That's basically what it's for. So it reckons that when you press A, you're then going to press B. So it recognizes that you might do that next and basically gets it done for you. That way it speeds the process up in the program that you're running. Well, that's most of the stuff covered for you. That's 9 minutes of information. I hope I haven't lost you too far. This particular board hasn't got any markings on it apart from this one up here, which is fairly benign is the best word to use. Okay, there is an additional letter there, but so I don't really want to peel back the warranty void if removed logo. So it says 386 WB4A3.B1. The other word of note on this board is I did take off the battery, which had started to leak and corrode the board. I just simply got a tin snips and just cut it off. The computer will still function without that battery, no problem at all. The only problem is that every time you turn it on, it'll have amnesia. So if you're using the computer for running old programs, you'd have to set it up first and just hit the reset key when you wanted to, load another program up. It's not really all that much of a problem. Personally, I've taken battery out of a few machines like this, and resetting the BIOS up on them is fairly straightforward because the BIOS in them is pretty good, and it'll automatically detect the hard drives, the floppy drives, and stuff like that. It is a pretty good BIOS, so problems aren't a problem, if you know what I mean. The other thing about this board is I did run Windows 95 on it, but it was like treacle, very hard to run it, and it just didn't work very well. Another little thing of note here is if you've never seen these little fellas here before, they're known as resistors. The stripes indicate the type of resistor that it is, so there's another little bit of information for you. Okay, that's basically it. Hope you enjoyed this short video, and I'll see you on the other side. Good luck, and thank you for watching, YouTubers.